In this video, we will discuss about count the number of fair pairs. Given a zero indexed integer array nums of size n and two integers lower and upper, return the number of fair pairs. Pair I comma j is fair if I is less than j and nums of I plus nums of j is greater than equals to lower and less than equals to upper. So what they are saying is that in the input, we are given an integer array nums and we are given two integers lower and upper. We need to find out the number of fair pairs that exist in this array nums. Now for a pair I comma j to be a fair pair, there are two conditions. First is that I should be less than j, right? And the sum of these two, that is nums of I plus the nums of j, should be greater than or equals to lower and smaller than or equals to upper. Meaning this sum should be in the range lower and upper, right? So whatever are the number of such pairs, that count you need to return as your answer, right? So now how can we do this? So see, one of the basic and simple brute force approaches to identify all the pairs out of this nums, right? Wherever I is less than j, basically you can run one loop for I, which will fix the I element, and you can run another loop for j, which would start from I plus 1 every time, and then you can do the sum, and then you can check that if it is lying within the range of lower and upper, that is this, then you can count that pair, right? And at the end you can return that count. But this nums array, that can be of size 10 to the power 5 in worst case. So when we are running two loops of I and j, our time complexity will be n square, which we cannot do in the case of 10 to the power 5. So we will have to think of something else, right? So see, this is the equation that we have to focus upon, that the sum of these two numbers should be within the range of lower and upper, right? So if let us suppose that every time I have fixed my nums of I am iterating in this nums, right? And I am fixing my nums of I. Now, for that particular nums of I want to identify that how many nums of j are there for which if I do their sum, then it is within this range, right? So, I am fixing this nums of I. So, if I am fixing nums of I, can this equation be rewritten as lower minus nums of I less than or equals to nums of j less than or equals to upper minus nums of I? So basically, what I did was that I added minus nums of I in all these three, right? Then here this will become lower minus nums of I. Here this will be cancelled out with that negative, right? So only this much will remain, and here it will be upper minus nums of I. So this equation can be rewritten as this, right? Now I have fixed my nums of I every time. So in the first iteration, my nums of I will be 0. In the second iteration, it will be 1. In the third iteration, it will be 7, and so on, right? So when in my first iteration, my nums of I is 0 and lower is 3 and upper is 6, then what will be my equation in that case? It will be 3 minus 0 less than or equals to nums of j, or let's denote it with x, right? And this should be less than or equals to 6 minus 0. So we can say 3 less than or equals to x less than or equals to 6. Then if I am able to identify that how many elements are there which are within this range 3 to 6 in my nums array, if I am able to identify that, then whatever will be that count, can I say that will be the number of fair pairs where our nums of I will be 0 and nums of j will be all those numbers, right? So see, our range is 3 to 6. Let's just look at this nums array, that how many numbers are there which are within this particular range. So 0 is not, 1 is not, 7 is not, 4 is within the range, this 4 is within the range, and this 5 is within the range. So there are total 3 elements. So then that means with this 0, we can have 3 pairs. One is 0, 4, other is also 0, 4, and the other is 0, 5. So these are the 3 pairs. So within this range, we got 3 numbers from this nums array. So we can say that for 0, we are having total 3 fair pairs, right? So if we do this similar thing by keeping all the elements as nums of I one by one, then we will be able to identify all the fair pairs, right? So this is what we need to do. So now for finding out what all numbers are there in your nums that are within this range, again you will have to perform linear search, right? You will go in nums, you will check, okay, 0 is not between 3 and 6, 1 is not between 3 and 6, 4 is between 3 and 6, right? So again your time complexity is going to be n square, right? So now how can we optimize it? See, we need to identify what all numbers are there between this range. This range is nothing but 3, 4, 5 and 6, right? This is a range. And these numbers, if I say are sorted in increasing order, right? So what if I sort this nums array? So if I will sort this nums array, then what I will get? So this will be 0, 1, 4, 4, 5, 7, right? So now after sorting, my nums array will become like this, right? So now when I want to identify that how many numbers are there that are within this particular range, I can simply apply the concept of lower bound and upper bound in this nums, and I will be able to get how many elements are there within this range. So see, now what is a lower bound and upper bound? So see, a lower bound is nothing but lower bound and upper bound are C++ functions. So let's understand what do they exactly do. So if let us suppose this is my array and I am applying a lower bound on 4, right? So what it will do is that from this array, it will return an iterator pointing to the first occurrence of 4 if 4 is present in my array, right? And if 4 is not present, so let us suppose I apply lower bound on 3 over this nums, then in that case, it will return an iterator pointing to the next element which is just greater than 3, which in this case is 4. Right? So when I will apply a lower bound on 3, it will return an iterator pointing to 4. And if I apply a lower bound on 4, then it will return an iterator pointing to the first occurrence of 4. Right? So this is what lower bound is. Then next is what I'm saying, upper bound. Right? So upper bound basically returns an iterator pointing to the first element which is strictly greater than that value. So basically, if I am applying an upper bound on 5 in this nums, then it will return the iterator pointing to the next greater element than 5, which in this case is 7. So upper bound will return this 7, right? And if in case I apply it for 3, then what will happen? Again, it will return the iterator pointing to the next greater element, which in this case is 4. Right? If I am applying upper bound on 2, in that case also it will return 4, because after 2, the first largest element after 2 is 4 only, right? That is why. So this is how lower bound and upper bound works, right? So now I am saying if I am applying lower bound for 3 and upper bound for 6 on this nums, then what are you going to get? So let me just remove this. So when I will apply on 3 lower bound, I will get an iterator pointing to this, right? So let me just write the indexes 0, 1, 2, 3, 4, 5, right? I will get an iterator pointing to this 4, right? Next, when I will apply an upper bound on 6, then it will return me an iterator pointing to this 7, right? When I will do the difference of these, which is 5 minus 2, then I will get 3. Are there 3 elements in this nums array which are within this range? Yes, 4, 4 and 5, right? So on this I can apply lower bound, on this I can apply upper bound, and then whatever I'm getting, if I do its difference, I will be able to identify that how many number of elements are there in this nums which are within this range, right? And lower bound and upper bound functions in C++ take time complexity of log of n, right? So our overall time complexity will be n into log n, which will work for 10 to the power 5 also, right? So what we are doing is that firstly, we have sorted this array, right? Then we are fixing our nums of I. We are iterating in this nums. We are fixing nums of I. So we are applying lower bound on lower minus nums of I and upper bound on upper minus nums of I. And then whatever we are getting, we are doing its difference and then we are adding that count somewhere, right? Now another thing to notice here, we were having one more condition which is I less than j, right? So then that means if I have considered 0, 4, I cannot consider 4, 0, right? Again, right? But if you will just do only this, what we have discussed till now, then it will be counted twice, right? But we need to think of this condition as well. Now see, although we had sorted this array, so we would have lost the original indexes, but we do not care about the indices. Why? Because we are doing the sum here. Nums of I plus nums of j is always equivalent to nums of j plus nums of I, right? Because sum is anyways going to be the same. The only thing is that one pair should not be counted twice, right? So for that, what are we going to do? So if you closely look here, that if let us suppose that we were at this element 4, in that case, what would happen is your equation will be 3 minus 4 less than equals to x less than equals to 6 minus 4, which is minus 1 less than equals to x less than equals to 2. Now, within this range minus 1 to 2, you are having two elements here, 0 and 1. But you see, for the 0 with this 4, we would have already counted the pair. And before we come at this 4, then the pair that this 1 would have with this 4, that also we would have already counted, right? Then that means whenever I am at this 4, then whatever are the numbers which I have already considered, I should not consider them now in my array, right? So when I am at 4, then I should start considering elements from here, right? Because since I is less than j, so this 4 cannot create a pair with itself, right? It can only create a pair with these elements, right? So whenever you are at 0, you will consider this much part of the array to find out the numbers between within this range, right? When you are at this 1, you will consider only this much part. When you are at this 4, you will consider only this much part, and so on, right? So the only thing that you need to do is that whenever you are applying your lower bound and upper bound function, so there you need to mention three things, right? So basically, lower bound and upper bound takes three parameters. First is an iterator pointing to the starting of the vector. So in this case, the name of the vector is nums. So what we do is we write lower bound, and then inside this we write nums dot begin. So this denotes the starting point. And then we write nums dot end. This denotes the ending point. And then the third parameter is the number on which we want to apply the lower bound. So which in our case will be lower minus nums of I, right? And similar thing we do for upper bound also. So this function is upper bound, this is nums dot begin, nums dot end, and this will be upper minus nums of I, right? So now the only thing that you need to do is that instead of nums dot begin, what you will write? Instead of this, we will write nums dot begin plus I plus 1, right? So that whenever we are at the index I, we consider from the index I plus 1 for finding out the lower bound. Same thing we are going to do for the upper bound. So with that, we will be able to check for this 4 only this much part of the array. We do not have to check the entire array. So that's how we are going to solve this problem. So let's quickly code it out. So first of all, we are going to create a counter variable which will initially be 0. We need to return a long long, so that is why it is long long. Now we need to sort our nums vectors, comma nums dot end, right? Now we need to start iterating inside our nums vector. So we will start I equals to 0, I less than nums dot size, I plus plus, right? Now we are fixing our nums of I and we are trying to identify the upper bound and the lower bound for nums of I, right? So it is going to return us an iterator. So we will write auto low. So here we are applying lower bound. So it will be lower bound, right? And then inside this, what we need to pass is we need to pass nums dot begin plus I plus 1, right? And the ending will be nums dot end. And then on what element are we going to apply lower bound? Lower minus nums of I, right? And then we will apply for the upper bound. So it will be auto high equals to upper bound. Inside this, we will pass nums dot begin plus I plus 1. Ending will be nums dot end. And what will be the number on which we are applying upper bound? It will be upper minus nums of I, right? Now what are we going to add in our count? Count will be plus equals to high minus low, right? And at the end, we can simply return the count. And here, what is the time complexity? So here we are sorting it, which is taking n log n. Here we are running a loop n times. Inside this, we are using lower bound and upper bound, which is also taking log n time. So the overall time complexity of our code is going to be n log n, right? So let's quickly run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.